welcome everybody who's listening to my talk. This particular talk is about the autonomous cars and how the machine learning method, which is called the neural networks, plays a very important role in this autonomous car driving. So now I will be showing you the slides which I will be using. Okay, so here is the title of my talk, which is The Brain Behind Autonomous Cars, Deep Learning. So this is the outline of my talk. I will be covering, first of all, the components of autonomous cars that allow self-driving. And then after that, technological advancements which have made autonomous cars possible. So there are many advancements have been made which allows us to have autonomous cars. Then after that, we're going to talk about the neural networks, the history of neural networks, because the brain behind the autonomous cars is neural networks and deep learning. So we have many layers of neural networks. So we're going to talk about that. Then after that, we're going to talk about the convolution neural networks. And then I will talk about the availability of billions of digital images, which are allowed, which has allowed the deep learning method to learn from those images, because it is a machine learning method. So if machine has to learn something only by looking at different images. So we need a huge collection of these images. So these collection of images have been created, and these neural networks learn from those images, and from there they are able to identify what is there in these images. So the availability of the GPU, which is graphical processing unit, play a very important role in the autonomous cars. So neural networks basically learn from GPU. And there is a company called Nvidia. Nvidia makes the GPU that allows us to basically process those images faster. So this allows us to build these networks, by which we can have autonomous vehicles. Okay, now autonomous cars are going to be there, in the sense that they are already coming. And the major advantage of an autonomous cars, of course, is that it improves the productivity. Instead of the people driving the car, they will be sitting inside the car and just doing something else, because the car basically drives all by itself. And of course, there will be fewer accidents, so less loss of property and life. But the cons of this new technology, of course, is loss of employment for taxi and truck drivers. So that's always happens whenever a new technology comes up. There are always going to be some people who will be displaced by that. And also there will be a loss of privacy. Loss of privacy means that if the car is driving all by itself, it has been that the car is communicating with other nodes on the network. So there is no privacy left. Once the information is out that a person is moving from one point to another point, then of course that information will be recorded and will be shared. So these are the primarily the pros and cons of autonomous cars. Now there are 5 different levels of automation. Level 1, of course, is the cruise control that we used to have almost from the last 30-40 years. And then after that, from the last 10 years, we are having the feature of self-parking. Now we have reached at level 3, where the car can drive all by itself on a highway, and the steering control is there. But on level 4, we have not reached there yet. Street driving means anybody can drive basically on any street. Some cars can do that thing, but not a whole lot of can do this thing. So we are between level 3 and level 4. The level 5 is the ultimate goal, where you punch in the GPS locations or the coordinates of your destination, and the car basically is just going to take you there. We have not reached at level 5 yet, but we are very close to it. And hopefully within 5 to 10 years, we should have cars with level 5 of automation. So this is the way a level 5 car is going to look like. Like people are just sitting in the car and the car is just driving by itself. So that is the future, right? And we would be there within a matter of maybe 10 years, 15 years, 20 years, or who knows, maybe could be sooner than that. So this is a level 5 autonomous cars. Now, when we have a human vision, in human vision we have, of course, the eye, and then we have the brain. Brain basically tries to understand the image. That's the way the human image basically works. But in autonomous cars, we have the cameras. We have built cameras long time back. From the last almost 20 to 30 years, we have digital cameras. But we did not have the brain to understand those images. So now we have reached at that point where we have the neural networks with deep learning acts as a brain. So now we have a complete human vision. And this thing, which is camera per the neural network with deep learning, allows us to understand what are the objects in front of a car. And based on that understanding of that image, then a car can take decisions, whether to turn left or right, or stop the car or speed it up. So all these decisions have been made because a car can understand those images. So my talk is all about the neural networks with deep learning. So now, first of all, let us look into the components of autonomous drivings, so which allows basically self-driving. So these are some different components of self-driving. So these are the components. First one, of course, is the LiDAR. LiDAR is actually is a light detection and ranging. So LiDAR is very similar to radar. Radar uses the radio waves. And as you know, that cops basically use radars to find out the speed of the car which is driving next to them, so that they can give some speeding tickets. So in the difference between radar and the LiDAR is that in radar we use the radio frequencies, whereas in LiDAR we use the lasers. So lasers are becoming very, very popular. But right now, the price of the LiDAR is very high. But in some cars, they have started using it. And then after that, they have the LiDAR, they have a radar, they have ultrasonic sensors. These are the audio sensors that can locate it all around the car. Then they have a front camera. Then they also have digital maps, which are high definition digital maps. So they know exactly where they are. And so, and also they have high precision GPS. So these are the components of an autonomous car that allows the cars to run smoothly. So this is a LiDAR. LiDAR, as you can see, is located right in front of the car. And there is a laser beam that goes in front of the car till 700 feet. And so this basically detects all the objects which are there in front of it. So this beam is kind of continuous. So we can continuously, the car has the ability to sense what is in front of it and how fast that particular car is moving, and all that information about in front of the traffic. And let me remind you that this is not a camera. This is just a LiDAR, and that is looking into the objects which are in front of the cars. Then there are a lot of ultrasonic sensors. So these ultrasonic sensors are located all over the car. These are basically trying to find any objects which are right next to the car. So usually there are 12 of them, or sometimes more, depending upon which model of the car it is. And these audio sensors basically transmit some audio waves. And when that wave is being reflected from the object which is right next to it, it can sense that thing. So this way they can detect how far that particular object is. The third one, of course, is the camera. Cameras are located usually where the mirror is in front of the vehicle. Usually on the back side of that mirror, there is a camera. And this camera, it basically looks around, and just by looking at it, it can sense what is what are the objects in front of the camera. Then we have the sensor range. Sensor range we have, so these are all different tools which are there in the car that allows us to basically move the car forward. So there are many, many different objects are there. We have a LiDAR, we have the camera. So as you can see that the autonomous cars can basically sense it can sense the objects in front, in the back, or also on the side much better than the human can. So these are the different sensors for an autonomous cars. Now, next I will be focusing primarily on the neural network and also the deep learning method. Okay, so when the car is moving, this is what the car is going to see. See, when the car is moving, the car has the ability to see there is a truck on the left-hand side, there's a car again on the left-hand side, and there's a car right in front of it. And it can also read the signals. So signals is one is red or green or yellow, whatever the case may be. It can also see the car on the right-hand side as well. So this is the car view. Car can see all these objects, and just by looking at these objects, these cars can make a decision on in which directions do we go. So what are the technological advances which have been made for the autonomous cars? So first of all, we have the convolution neural network with deep learning. That is the brain behind the vision system. And also the availability of the billions of digital images which are there. And these images are required primarily to train the neural network. And also the availability of GPUs. So like Nvidia is a company that makes the GPUs. So if you have a GPU in your processor, then you can process those images faster. So the neural network basically needs millions of images to digest. If you don't have a GPU, then usually it takes 1 to 2 months to digest all of these images. There are millions of images are being thrown at the neural network during the learning stage. Now, because of the GPU, that time can be reduced from 2 months to a few days or maybe 2 days. So that is the reason why having a GPU makes a lot of difference. So these are the 3 different technological advancements that have been made that has made autonomous cars possible. So now let us look into the neural networks with deep learning. And this is the brain behind the autonomous cars, which are neural networks and deep learning. So let's look into the history of neural network. And so first question comes up is that why it is called a neural network? Because the system that we are trying to build basically mimics, so it's very, very similar to the human brain. So that is the reason it is called a neural network. So, and as you know, human brain is very difficult to understand that how it works. We are still trying to figure it out. But so here basically we have some inputs to a network. This is one of those logistic regression. And it has his own weight, and once it crosses a certain threshold, then it triggers. So then it goes to the next stage of the neural network. So, and then we have many different layers of neural networks, and then this basically becomes similar to the human brain. So that's what basically we are trying to build here. So the concept of neural network was promoted by Warren McCullough and Walter Pitch in 1943. But they never built anything. It was just that this was just an idea form. And they basically said that if we had a machine of this type, then we can build neural networks. But of course, in 1943, we did not have any, we did not have the technology to build these things. Then in 1957, the first physical neural network was built by Frank Rosenblatt. And he was working at Cornell University. and he built a perceptron. Perceptron was a very, very simple, neural network based machine. Now, it is hardware based, means it is based on hardware, and then it basically tries to learn something. So if you're going to project a triangle or a circle or a square in front of it, it can detect that thing. It can tell, yeah, this is a triangle, this is a square, this is a circle. So this thing was done. Again, it was very, very elementary. This whole thing is just similar to making a first aircraft, which was built in 1903 by the Wright brothers. It just flew for 2 minutes, but basically it just showed that we can build something of this type. So this was the year 1957. So perceptron, which was built by Frank Rosenblatt, had a single layer with 8 neurons. And of course, not these days we have 150 layers and billions of connections. So now compared to the neural networks that we have in the present day, which are used to detect the images, this particular neural network, which was there made by Frank Rosenblatt, Blatt was very, 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 very elementary. So now, when this neural network was being built, at that time it was hyped by Rosenblatt. As you can see, this is a 1958 archives of New York Times. And basically, it says that a new Navy device learns by doing. Psychologist shows embryo of a computer designed to read and grow wiser. And the New York Times story basically says the Navy revealed the embryo of an electronic computer today that it expect will be able to walk, talk, see, write, reproduce itself, and be conscious of its existence. So, of course, we have not reached there yet. This was totally a hyped up thing. And one of the reasons why in the early stages, neural networks kind of died because people have a very high expectations from neural networks, but it was not able to deliver that thing. So of course, this was just purely a hype thing. But anyway, this was Rosenblatt was trying to portray. So this idea of the perceptron was criticized by Marvin Minsky. Marvin Minsky was a professor at MIT, and he basically came up with a problem of XOR problem, and he says that hey, your system cannot even learn XOR pattern, and he proved that thing. But of course, Marvin Minsky was using single layer perceptron, so single layer cannot do it, but a multi-layer, of course, can do that. But at that particular time, I mean, maybe did not have the multi-layer neural network. So this is what XOR problem is. XOR problem basically says that if there are two inputs of 0, output will be 0. If it is 1, 0, it is 1, 0, 1, it should be 1, and 1, 1 should be 0. So this is the XOR problem. Can the system able to determine this kind of a pattern in the data? No, it cannot. If it is a single layer, it cannot be. But a multi-layer, of course, it can be. So Marvin Minsky basically attacked on this idea of this XOR problem. So then later on, Marvin Minsky basically said that neural network is not the way to go. This is nothing is going to come out from it. So, and he also published a book in 1969, which basically says that the neural networks are fundamentally limited. And that is the reason why suddenly the complete research got stopped in the area of neural networks, because Marvin Minsky was against that thing. So this is Marvin Minsky. Basically, he was said that if you want to do artificial intelligence, he has to come up with different techniques of understanding the problem and trying to program those problems in. But the idea of a neural network was killed by Marvin Minsky at that particular time. So as you can see that this concept of neural networks was started, and then it suddenly died. Then again in 90s it came back, but for a short period of around 20 to 30 years, nobody was working on this concept of neural networks. But now, of course, things are just the opposite. Now, of course, there's a lot of work going on, and neural networks have established themselves. But the matter of around 20 to 25 years, temporarily neural networks idea kind of died. So, and then unfortunately, Frank Rosenblatt also died on July 1971 in some kind of a freak boating accident. He used to work at Cornell. So there he died. So because of that reason, neural networks, again, that area basically kind of died. And then after that, in 1974, Paul Verbos basically introduced the concept of back propagation. And Paul Verbos was from Harvard. He developed this concept of back propagation, which improved the neural network significantly. But the problem with this thing is that the system overlearned, becomes overfit. So again, the real world results was not there, but fundamentally neural networks changed, because now if you're going to have multi-layer with a back propagation, then of course things improve significantly. But again, it was never been accepted in the real world because it couldn't solve the real world problems. So Paul Verbos also solved the XOR problems using the multi-layer neural network. So now we have the multi-layer neural network with the feedback, with the back propagation. But the problem with this approach is that the model becomes overfit and works very well for the training images, but did not work very well with the test images. So again, it was an overfitting problem. Once again, neural network kind of died because nobody took it seriously, because it was not producing good results. Then in 1990, there was another machine learning came up, which was called support vector machines by Vladimir Vapnik. And the performance of support vector machine was better than the neural network. And the reason why support vector machine became better, because it avoided overfitting. And then everybody went after support vector machine, and then we think that this is the way to basically do these things. But neural networks basically came up again in light in year 2000 and above, when again much more research was being done in this area. So then after that, there was these two scientists, Hubble and Wiesel. They were detecting how the images are being perceived by humans. So they basically connected actually a cat retina, and they found they connected some electron or some scopes to the retina, and they proved that thing when the images are going to see some edges, that is the way our human vision works. So these people basically gave the understanding of how the human vision basically works, and for their work, they were working at Johns Hopkins, and for their work, they won the Nobel Prize actually in medicine in 1981. So this was a very, very important piece of work which was done, that how humans can see the objects. So human can see the objects from the edges, and that was being confirmed by Hubble and Wiesel. So this also may kind of contributed towards the neural networks to see what these images are. So neural networks always are programmed to look at the edges, because that's the way the human vision basically works. Okay, then they started a new kind of a network, which was called convolution neural network. And this area basically started. So in the case of a convolution neural networks, what we have is that we perform the convolution operation in the first stage. So the convolution operation is something that we do with the images. And so this thing was being proposed by Professor Fukushima. Professor Fukushima was from Japan, and he said that if we use the convolution neural networks, we can get better results. So he was earlier a professor at Osaka University, and then after that he went to the Tokyo University of Technology, and his basically work was on the convolution neural networks. So now, if we have the ability to detect the edges, and also if we can do the convolution neural networks, we can achieve something. So these are the building blocks for the autonomous cars. Autonomous cars have the vision, and the foundation of vision is that convolution neural network, and also the edge detection. So these things basically allow them for us to see. So this is the convolution operation. As you know, we have a filter first, and filter basically glides over the image. And then as it is gliding over, it is sliding over the image, we multiply these terms together and then add them together. So in this case, if my filter has -2, -1, 0, -1, 2, and now this is my image 0, 1, 2. So if I multiply 0 multiplied by 0, -1 multiplied by 1, and -2 multiplied by 2. If I'm going to add these numbers together, that becomes my first value. So this operation is called convolution operation. So first of all, we do the convolution, and then after that, we apply the neural network. So that's the way things work. So we do the convolution throughout the whole neural network, and as we are doing it, then we have the ability to recognize the images. So convolution neural networks are the ones that allow us to understand what the image is. So then after that, we needed to have the billions of images, because to train a neural network is not that easy. You need to have billions of electronic images. And at that particular time, images were not available. So as you recall, that thing, iPhone 5 basically came about around 2005, 2006. Before that, there was to capture an image, you need to have a very expensive camera, and there were not a whole lot of images available. So that is something that was done by which we were able to capture a lot of images later on. And when these images were being captured, and using those images, these neural networks were being trained, then we got the vision primarily. So now, how to capture the data for neural networks? So now we have to collect a lot of images. So because of that reason, and that images were not available at that particular time, we couldn't do with neural network. But once the digital cameras started coming out, people started building a lot of libraries of millions of images that can be used to train the neural network. So Professor Fifi Lee, she is at Stanford at this time. She was doing a PhD at Caltech, and then she collected millions of images and divided them into different categories. And then these images were being classified by the Mechanical Turk workers on Amazon. In Amazon, people were being paid a few pennies to basically kind of categorize these images. So, for example, if there is a image of a cat hiding behind some object, so the person, of course, humans have the ability to see that thing. So the humans can say, this is a cat, or this is a dog, this is a flower, this is an aeroplane. So everybody who was able to diagnose these images or able to identify these images were being paid a few pennies per images. So of course there are thousands of people basically worked on to categorize these images. So now if the images are being fed into neural network plus the classification, then the neural network has the ability to understand exactly what these images are. So this was a huge project that was done by Professor Fifi Lee, who was at that particular time at Caltech. Then the third thing that made this whole thing possible was availability of the GPU. If a neural network is supposed to digest all these images, it requires a lot of processing power. But now if you have a GPU, then you can speed these things up. So the heart of the deep learning method are the GPUs, and GPUs are called the graphics processing unit. They were actually developed for the gaming industry. So now but these things were primarily used to digest the images. So they also have several processors in them. They can run in parallel. So with the availability of the GPUs, neural networks finally became a reality, so that now we have the ability to digest these images and to make some sense out of it. So one of the major players in this industry, of course, is Nvidia. Nvidia GPUs are used for deep learning, artificial intelligence, and so these GPUs are also available in all Tesla cars. Tesla basically contains these cameras by which Tesla can drive up to a certain extent, all by itself. So neural networks tend themselves to, actually for parallelization, and GPUs basically provides the parallel processor. So this way, the amount of time it takes to train a neural network has been reduced. So suppose if you have, let's assume 5 million images. Now you're going to take, if you want to train your neural network using 5 million images, then it's going to take 3 months time. Means the machine is running continuously for 3 months. But now if you have a GPU installed in your computer, then you can reduce that thing from 3 months to 2 or 3 days. So as you can see, there was a significant improvement was been made because of these GPUs. So now once these GPUs are used, neural networks are trained, and once these neural networks are trained, then they have the ability to see these images, not only see the images, but make some sense out of these images. So here is the Nvidia GPU, which is used primarily. This is just one of them. Nvidia makes many different type of GPUs. So this is just one of them. So these GPUs are installed in cars. As you can see right on the bottom here, car has the ability to see these edges of these objects. So the car knows that there's a left car on the left hand side. There's someone who's riding a bike in front of it. So all these objects now can be recognized by the system. And once you have the ability to recognize these objects, then of course car can drive all by itself. So this is basically this thing can be achieved using the Nvidia GPUs. Now let us look into the last phase, that what basically made this happen. So we were looking into the vision of the autonomous cars. Okay, so now in 2010, again the same Professor Fifi Lee, who was at Caltech, started a competition, and she basically released around millions of images and allowed everybody to bring their system and also have a competition that who can recognize these images faster. So this competition generated a lot of interest. So there were 100,000 images, and the issue was who can identify these images correctly. So these were the results. So as you can see, in 2010, the incorrect were 28%. So they were using neural networks for that. But in 2012, this is the one that basically changed the whole industry. Now they have reduced the incorrect from, it dropped from 25 to 15, and they started using the convolution neural network. So convolution neural networks is the one that are being used for the image recognition. And this thing was done basically by Professor Jeffrey Hinton of University of Toronto. And Alex and Ilya, the other two students, are the graduate students at University of Toronto. This was a thing that basically we moved into a different phase. So now we are using the convolution network. We are detecting the edges. We have the availability of millions of images that can be used to train the network. So now we have reduced that percentage incorrect from significantly down. And look at what happened in 2013, that the percentage correct was 6.6%, which is has significantly lower. And this particular competition was won by Google. And then, of course, it went down further to 3.57 by Microsoft. But so the main thing by which these things changed was by the use of convolution neural networks. So this is a picture of Jeffrey Hinton and those two students, Alex and Ilya. These are the people basically who moved us into the final stages of the image recognition. So now if we use the convolution neural network, then of course we have the ability to understand what that image is. And that is a picture of Professor Fifi Lee. She has also given a very, very nice talk at TED. TED, as you know, produces very good talks. So she has also given like a 20 minutes, around 18 minutes talk. So you can just search on YouTube, just search for Fifi Lee and TED, and you will able to get this video. So this video basically shows you that how she built this whole thing, the human vision. And now this human vision is the one that is being used in the autonomous cars. So basically, that's the way by which she basically tells a story on that how she built that thing. And right now there is more research going on. She's a full-fledged tenured professor at Stanford, where she's doing more research in the area of human vision and also in the area of neural networks, which are the deep, using the deep learning neural networks. She's working on that problem. So now inside the network, let's look into that. Every layer of a deep learning network contributes toward the recognizing some aspect of an image. So using usually neural networks usually have 100 layers or 150 layers. Now just compare to this thing to Rosenblatt's, which was the first neural network came about, which has only one layer and 8 neurons. Now, of course, we have billions of neurons in our neural network. So the idea that Rosenblatt had was a brilliant one. It was just that is the way he built it. But at that particular time, he did not get a much success because we did not have the technology at that particular time to build a full-fledged neural network. Now, using that fundamental idea by Rosenblatt, now we can build this neural network, and because of that reason, now we have the understanding of the images. So the camera installed in the car can recognize these objects. And once you recognize these objects, then of course we can control the car. I mean, so controlling the car is very simple. Applying the brakes, speeding it up, taking a left turn, taking a right turn. All those things are very, very easy. That's all mechanical aspects that we know how to control. But understanding where to take a turn, when to stop the car, when to accelerate the car, those are the things that we can learn from. Neural networks. So neural networks basically allow us to have the deeper understanding of the things that are around the car. So this is called deep learning. As you can see, if you use a deep learning, these are the images that you're going to see as the car is going to see. So as the car is moving along, then car sees that there is a bike in front of them. There is some people in front of it. There are also 2 other people who are walking. So first layer of the deep learning, of course, is the edge detection. Second layer is convolution. Third layer may respond to some other pattern resembling the round of the wheels. Fourth layer may respond to the shape of the car. So this way there are 150 layers that have the ability to basically recognize these images. So this allows us to have the vision in the car, and so the car can drive all by itself. Now, there is also this video which is available from Nvidia. If you go to Nvidia website, you can see this video. And here you can see how the car can recognize the objects which are in front of them. So once we have the ability to recognize these images, then of course we can drive. So this is the foundation on which these autonomous cars are being built. So let us try to summarize what are the different technological advancements which have been made for the autonomous cars. The first thing is convolution neural network with deep learning, availability of the billions of digital images to train the neural networks, and the availability of the GPUs. So these 3 things allow us to have the autonomous cars, because these 3 things become now the human brain, and the brain can basically recognize what these images are. So let me kind of review one more time. What do we have here? Here, basically, as you know, for a human vision, We have the eyes and the brain. That's the only thing that humans can able to understand it. Eyes are just equivalent to the camera. So your eyes can see the objects, but your brain basically understands that thing. So when from the optic nerve of the eye, when these things reach the brain, then brain has the ability to recognize these objects. So similarly, now in an autonomous cars, we have a cameras which are equivalent to the eyes, and the neural networks with deep learning is the brain. So the brain behind the autonomous cars, of course, is the neural networks with deep learning. So that is the end of my talk. So thank you very much for your time. So as you know, I basically covered the brain behind the autonomous cars, and this is nothing but neural networks with deep learning. Thank you. If there are any questions, if you can just type your questions, I will answer them. Is there other emerging technology other than you presented? Not really. If you look into the human brain or how the card basically looks into this data, it is neural networks with deep learning, and they build basically convolution neural network. This is the direction where the research is going on right now, and it has been very, very effective. Not only Tesla is using this technology, but Mercedes is also coming up with this idea, and as you know, Toyota, everyone is working on this idea. Now they are building a neural networks and training the neural networks with the images, and of course, everybody has a different kind of a neural network, but the fundamental ideas are is the same. So there are no other technologies that I know basically which is coming up. Now, the next question is, will car-to-car communication be needed in autonomous cars in the future? Yeah, maybe you can. I mean, once your car is connected to the internet, of course, the car will start communicating with other cars also. So that thing, of course, will be coming up. And once you're connected to the internet, and of course, you can communicate with other people. Cars can communicate, and a whole lot of things can happen. So next question is that will neural networks be good for real-time control system? Yes, it all depends upon what kind of a problems you are solving. See, neural networks are very good for these three applications: image recognition, speech recognition, and natural language processing, because neural networks are designed primarily where you have some data which is abstract. It's very difficult to formalize what an image is. So, like the way, in fact, humans also basically learn from the same technique. When a child is born, by the time the child reaches the age of around 1 year, child looks at millions and millions of images, because every few microseconds the child is looking at these images. So the child basically learns from it. So there is no way someone can describe what an image is. Only you can see by example. So those areas, those applications where there are no very defined rules, then you can use neural networks for those applications. And these three applications are primarily image recognition, and the speech recognition, and also natural language processing. But there are many other type of problems out there where neural networks may not be the best machine learning to use. We can use support vector machines for those things, or it could be regression, logistic regression, or could be principal component analysis. So there are many different things out there, from real world problems are there. But those problems which are very abstract in nature, like image recognition, natural language processing, these are the things where neural networks are very, very good for it. So since you're asking for a control system, I don't know what kind of control we have. You can try some other method as well. But if you have something very abstract like images, then neural networks can be used. The next question is, there are so many companies in the AV market. Do we really need that many players? So I think by AV you mean to say audio visual. See, this is not a question of audio visual. This is a question of image recognition. And there are not too many people who can do this stuff. because only now, as you know, these automobile makers like Tesla and Mercedes and Toyota and Audi, and these people are working in this area. So, but everybody using the same fundamental idea. The fundamental research is going on at Caltech and also at Stanford, where they are using neural networks, and also at University of Toronto under Jeffrey Hinton, Professor Jeffrey Hinton. So these are the three places basically where these things, research is going on. So there are not a whole lot of players in this industry. Now, next question is that is Google AlphaGo use convolution neural network? I don't know. I don't know what system is AlphaGo. But since it is a part of Google, and Google, of course, is a forefront in this technology, so they must be using it. I don't know specifically about AlphaGo, but the technology that Google uses for their automobile cars, of course, is a convolution network, so that's basically what it is. Next question is that can convolution neural network operate at the edge device without need of the cloud connection? Yes, it can work because the neural network has already been trained, so it can start recognizing the images. So the neural network does not need the cloud connection. The cloud connection is primarily needed for your GPS, so that we can see the complete map and a whole lot of other things. But the neural network has the ability to recognize it. So even if you don't have internet connection in your car, you can still, it's going to work. Okay, so I see, and now I see no more questions. So I guess that I just want to conclude my talk at this time. And so thank you very much for coming to my session. And this particular session is being recorded. I'm sure that if somebody wants to see that thing, they can look into this presentation later on. Okay, so thank you very much.